In this unit, we've been studying radicals. Remember that a radical is just a root. You can have square roots, cube roots, fourth roots, so on and so forth. In today's lesson, we're going to learn how radicals are related to exponents, specifically rational exponents, which just means that we're going to be dealing with exponents that are fractions. So radicals, which are just your roots, can be rewritten as a rational or a fractional exponent using this formula. Now, most textbooks would use an M and an N, or maybe an A and a B. Here I've used an M and an H, as you see in our equation. And the reason why I use that is to help you remember the rule here. If you have the hth root of x to the mth power, think of this as a house. The man, the M, is inside the house. The H, the horse, is outside of the house. Now, when you want to convert that to an exponent, just remember the man rides the horse. Okay, so the man is inside the house, the horse is outside the house. The man is inside the house, the horse is outside the house. And when you change it to an exponent, the man rides the horse. Now, that is the connection between roots and exponents. You can switch back and forth. So let's put this into practice. First, we're going to practice going from radical form into a rational exponent. So remember our rule up here. This is how we're going to convert back and forth. So what you want to do is you want to identify what those powers are. This first one is the cube root of x. Since this is just a regular old x, you can think of the first power here. So if I want to change that, the man rides the horse, the man is in the house, the horse is outside. So if we convert this, this would be x to the 1/3 power. Same exact thing on the second one. You have the 8th root of x, it's a regular x. You can think of that as x to the first power. So when you convert this to an exponent, remember the man rides the horse, the man is inside the house, the horse is outside. Okay, the third one, this is the trickiest one of all. This is just a square root of x. Now we see that there's only one x there, but what number goes on the outside for a square root? A square root would be a 2, right? Like a cube root is a 3, a fourth root is a 4, a square root would be a 2. So you have to write those numbers in. All right, so here we go. Switch it to an exponent. The man rides the horse, so x to the 1/2 power. The last two are actually easier. We are switching this to an exponent. Remember, the man rides the horse, so that would be x to the 3/7 power. And last, rides the horse, so that would be x to the 2/5 power. Now let's see if we can go the opposite way. So this time we're given an exponent and we have to change it back into radical form. So remember our formula over here. The man is in the house, the horse is outside, and we know that the man rides the horse. Okay, so here we go, switching this thing into a radical. Remember, the man rides the horse, the man goes in the house, the horse stays outside. I don't have to put that 1 there with the x. This is just the 4th root of x. Okay, the next one, we have x to the 1/5 power. We're trying to change this into a radical. So remember, the man rides the horse, the man goes in the house, the horse stays outside. So this one would just be the 5th root of x. The third one here, same idea. We have x to the 3/2 power. We're trying to change it to a radical. Remember, the man rides the horse. The man goes in the house. The horse stays outside. Now, if you're reading this is the square root of x cubed. You don't have to put that 2 out there. If you leave it like this, that still says square root of x to the 3rd power. The last two here, we've got x to the 2/9 power. Remember, the man rides the horse, the man goes in the house, the horse stays outside. We don't need to rewrite this one. There's nothing really unique about it. It'll just stay as is. And the last one, x to the 7/11th power. Remember, the man rides the horse. The man goes in the house. The horse stays outside.